So today we're talking about functions, domain, and range. Now we spend a fair amount of time studying relationships by mathematical modeling. That's that main technique that we use. These relationships can be classified basically into two types. There are things that we call relations. And the best example of that is your score on a final exam versus how many hours you spend studying. We agree that the more time you spend studying, the better your results will be, but it's not a direct one-to-one relationship. It's not like if you study 7 hours, you get 80, and then 8 hours, you get 90. If you study 9 hours, then you get 100. If you study 10 hours, you get 110, and it doesn't work that way. It helps, but it's not a direct one-to-one relationship. A function is. And the best example of a function, I think, is if you have a job or if you have had a job or you're going to get a job. The number of hours you work relates to your total earnings. And your pay is a function of how many hours you work. If you work, for example, 4 hours, you get paid $30 perfectly. Okay, this isn't a scatter plot where the dots are all over the place. If you work exactly 4 hours, you get paid exactly $30. That is a function. Now, algebraically, we've seen functions before written as these equations. And we have this idea of an input value for x, and we have this equation, and it kicks out an output value for y. So if we had, y equals x plus 3, if I started with 11, I know 11 plus 3 is 14. So 11 is the input, this is the function, and 14 is the output. Really, it comes down to thinking of a function as a rule that gives a single output number, which is y, for every valid input number, x. And we're going to talk about this in a few minutes, what it means to be valid. Now, the set of all valid input numbers is called the domain of a function. And the set of all valid output numbers is called the range of a function. So a function graphically has to pass what we call the vertical line test. So if you have a couple pictures here, any vertical line will only cross the function once. So for this one here, this example, this would fail the vertical line test. This example is not a function. Because if I draw a vertical line through the graph, I hit it at 2 spots. That fails. What that means is for this x value, an x can only create 2 y values. So for this x value, I'm creating a y value here and a y value here. That's bad. That's not a function. That's like you working for 3 hours and the boss is going to pay you $36 or negative $36. Okay, that fails. That doesn't make sense to us. A function is over here on this side. This passes. If anywhere along this line, this function, if I draw a vertical line, I'm only hitting it at one spot every time I hit it. Here one spot, here one spot, there one spot, and so on. Every x value can only have one corresponding y value. So for example, if you work your 3 hours here, you get paid exactly $36. There's no other value along that line. Now for us, for function notation, we have to change things a little bit. Function notation allows us to operate with functions really in a more efficient way. Really, it's pretty simple. We're just going to replace the y with this structure f of x, and we say f of x. So this is what it looks like. Before we've had an equation, y equals 5 times x, y equals 5x. Now we're going to have f of x equals 5x. Okay, similar idea. We had a linear equation, y equals x plus 7. And now we're going to have a linear function, okay, g of x equals x plus 7. The letter out front doesn't, typically we use f to represent function, but we can actually choose any letter we like out front. But it's this notation, it's f bracket x. That's a notation thing that we're going to use for functions. That's not a multiplying. This doesn't mean f times x. This is just f of x. It's how we write it. So the advantage of this is that, of course, say I'm given a function, f of x is x squared plus 2x plus 3. I can say find f at negative 3. And to do that, here's my function. I just replace the x with -3. I plug in -3 and so on. Now it's just BEDMAS, and -3 squared is 9. 2 times -3 is -6 plus 3 and so on. Gives me my answer of 6. So the same idea here. These statements all mean the same. If I have y equals 2x plus 3, that's a linear equation that we've seen. Now I can rewrite it just with different kinds of function notation, and I can turn them into linear functions. Okay, so y equals 2x plus 3, or f of x equals 2x plus 3, or g of x equals 2x plus 3, or h of a equals 2a plus 3. It all means the same thing. Same idea here with function notation. F of x, if I want to find f at 2, I just take 2 and I plug it in everywhere there's an x. So it'll be 3 times 2 plus 1. So 3 times 2 plus 1, which is obviously 7. Here's my function g of x. It's x minus 8. If I want to find g at 9, I just replace the x with 9. 9 minus 8 equals 1, and so on. Once we've identified a function, we need to determine for what x values the function exists. And to do this, we're going to talk a little bit more about the domain and range. This is important. If you think of your job, say you're working at a company, and you have your pay and you have your hours. We realize that if we say to ourselves, what can the hours be? If you're working at a company, say you have a part-time job, how many hours could you work? Could you work, well, maybe 1 hour a week? Sure. Or 2 hours a week, or 3? Yeah, probably. Maybe 10 hours a week? Probably. This is what we mean by the domain. The domain is all the possible values that really make sense for the x value, or in this case, the h value. Okay, the domain, it wouldn't be negative. Okay, you can't work -4 hours, so it wouldn't make sense to have the domain being negative. And also, it wouldn't make sense to allow the domain to get, up to 1,000. Can you work 1,000 hours in a week? No, you probably can't, so it wouldn't go that high. So the domain is just all the values of h, or x, that make sense. And then from there, once we've really decided what our domain is, that creates, or that basically with a calculation, which would be our pay, that figures out the possible values in our range. So, suppose you're making, $15 an hour. If you work 1 hour, you get paid, $15. If you work 2 hours, you get paid $30. If you work 3 hours, you get paid $45. So the domain is just all these numbers here, how many hours you work, and the range are these numbers here. The range is how much you're getting paid. That's it. Now, to look at that graphically, it's exactly the same idea. We just look at it in terms of a Cartesian plane. So the domain is all the possible values of x. Now, in a general function, sure, we could have negative values, but the domain is just all the horizontal values that could exist. Then the range is just all the vertical values that are allowed to exist. Here's just an illustration of that. So here's an example. Again, a domain. Here we have a quadratic. The domain is just all the horizontal values here to here, and the range would be all the vertical values there to there. You can almost think of it almost like a shadow that's being cast by the function onto the planes, or sorry, the axes, the x-axis and the y-axis. So the domain is x, and the range is y. Now, to be able to write this, suppose we're asked to identify the domain of the following function. Now, x can be any integer, 0 or greater. So x can be 1, 2, 3, and so on as we go. Now, x can also be any decimal. So, 4.7 and so on. Now, obviously, we can't just list off all the possible values of x. So we need a better way to write this. And since we can't list an infinite number of numbers off, basically, we're going to use what we call set builder notation. It's how we're going to write domain and range. So for this example here, this is said the set of all x. So the set, this is the set builder notation, the set of all x such that x is greater than or equal to 0, and x is an element of the real number system. That's what we've written here. Okay, so we can almost follow our way through this here. So it's the set, again, the set of all x such that x is greater than or equal to 0, and x is an element of the real number system. And really what that's saying is basically it says x is anything bigger than 0. X can be any value, any decimal number, any fraction bigger than 0. The x values here exist because the function there exists. Okay. For this one here, for the quadratic, the domain, we would just say the set of all x such that x can be any real number, because this function goes forever like this, so the x value goes forever there, and this function goes forever there, so the x value goes forever in that direction. So if x goes forever there and forever there, this means x can be anything. So that's all we're saying. X can be any real number. The y values, okay, my y value is here, and it goes in this direction. So my y values, the maximum value it ever hits is 2, and it has to be less than 2 because it's dropping below this. So this is like a number line here, and y is getting lower. So we just say a set of all y such that y is less than or equal to 2, and y is any real number. Okay, similar idea here for domain and range. Here's my initial value. Here's my 1. I'm just saying the domain, the set of all x such that x is bigger than or equal to 1. So here's the 1. X is taking off like that. And my range, y is bigger than or equal to 2, because my y starts here, and it takes off in 2 and goes like that, because the function looks like that. This one here, similar idea. My domain starts over here at 2 and goes in the negative direction. So x is less than or equal to 2. And my range starts at 0 and goes in the positive direction, because my function is taking off. So we're almost thinking of, as the function takes off, we have two components to think about. We have the x value to think about, and we have the y value to think about. So it's almost like here's the x value and here's the function. The function takes off. Those are the x values that go with it. And then as the function takes off, these are the y values that go with it. The circle has a bit of a restriction. The domain for this circle, it's down here at -7, and it's over here at 3. So this just says the domain set of all x such that x has to be bigger than -7, which is this direction, and x has to be less than 3, which is this direction. So x is anything in here, obviously. The same idea for the range. It looks like 1 is the lowest value and 11 is the highest value. So the range is there to there, like that. Similar idea here. We can say x can be anything other than 2. See how the function doesn't cross this line at 2? Okay, so it doesn't hit that value. So we just say x cannot equal 2. And similar idea here, y can't equal that value there at 4. It doesn't hit those values. Now here for this one, the possible values of x, the possible values of y. Notice one last thing. If the circle is filled in, if the circle is colored in, then we include the equal sign. It's bigger than or equal to. If the circle is not filled in, then we just say bigger than. We don't include the equal sign because it doesn't include the circle. Okay, try these questions. I say use tech where needed. You can use Desmos or a graphing calculator to help you with some of the graphs. Same one here. That's it.